Solder paste is a material used in the manufacture of printed circuit boards to connect surface mount components to the copper traces of the board. The paste initially adheres components in place by being sticky. It is then heated, melting the paste and forming a mechanical connection as well as an electrical connection. The paste is applied to the board by silk screening and then the components are put in place by a pick-and-place machine. Use: a majority of the defects in circuit board assembly are caused due to issues in the solder paste printing process or due to defects in the solder paste. There are many different types of defects possible, that is too much solder, or the solder melts and connects too many wires, resulting in a short circuit. Insufficient amounts of paste result in incomplete circuits. Head-in-pillow defects, or incomplete coalescence of ball grid array sphere and solder paste deposit, is a failure mode that has seen increased frequency since the transition to lead-free soldering. Often missed during inspection, a head-in-pillow defect appears like a small head resting on a pillow with a visible separation in the solder joint at the interface of the BGA sphere and paste deposit. An electronics manufacturer needs experience with the printing process, specifically the paste characteristics, to avoid costly rework on the assemblies. The paste's physical characteristics, like viscosity and flux levels, need to be monitored periodically by performing in-house tests. When making PCBs, manufacturers often test the solder paste deposits using SPI. SPI systems measure the volume of the solder pads before the components are applied and the solder melted. SPI systems can reduce the incidence of solder-related defects to statistically insignificant amounts. Inline systems are manufactured by Co-Young, CyberOptics, Palmi and Test Research, Incorporated. Offline systems are manufactured by Vision Master, Incorporated. Composition: a solder paste is essentially powder metal solder suspended in a thick medium called flux. Flux is added to act as a temporary adhesive, holding the components until the soldering process melts the solder and makes a stronger physical connection. The paste is a gray, putty-like material. The composition of the solder paste varies, depending upon its intended use. For example, when soldering plastic component packages to a FR4 glass epoxy circuit board, the solder compositions used are eutectic SNPB or SAC alloys. If one needs high tensile and shear strength, tin antimony alloys might be used with such a board. Generally, solder pastes are made of a tin-lead alloy, with possibly a third metal alloyed, although environmental protection legislation is forcing a move to lead-free solder. Solder paste is thirxotropic, meaning that its viscosity changes over time with applied shear force. The thirxotropic index is a measure of the viscosity of the solder paste at rest, compared to worked paste. Depending upon the formulation of the paste, it may be very important to stir the paste before it is used, to ensure that the viscosity is appropriate for proper application. Classification: by size equals, the size and shape of the metal particles in the solder paste determines how well the paste will print. A solder ball is spherical in shape. This helps in reducing surface oxidation and ensures good joint formation with the adjoining particles. Irregular particle sizes are not used, as they tend to clog the stencil, causing printing defects. To produce a quality solder joint, it's very important for the spheres of metal to be very regular in size and have a low level of oxidation. Solder pastes are classified based on the particle size by JEDEC standard JSTD005. The table below shows the classification type of a paste compared with the mesh size and particle size. By flux equals, according to JEDEC standard JSTD004 requirements for soldering fluxes, solder pastes are classified into three types based on the flux types. Resin-based pastes are made of resin, a natural extract from pine trees. These fluxes need to be cleaned after the soldering process using a solvent. Resin fluxes are no longer predominant. Water-soluble fluxes are made up of organic materials and glycol bases. There is a wide variety of cleaning agents for these fluxes. A no-clean flux is made with resins and various levels of solid residues. No-clean pastes save not only cleaning costs, but also capital expenditures and floor space. However, These pastes need a very clean assembly environment and may need an inert reflow environment. Properties of solder paste. In using solder paste for circuit assemblies, one needs to test and understand the various rheological properties of a solder paste. Viscosity, the degree to which the material resists the tendency to flow. In this case, varying viscosities of solder paste are desired at different levels of shearing force. Such a material is called thixotropic. When solder paste is moved by the squeegee on the stencil, a physical stress applied to the paste causes the viscosity to break down, thinning the paste and helping it flow easily through the apertures on the stencil. When the stress on the paste is removed, it regains its shape, preventing it from flowing on the circuit board. The viscosity for a particular paste is available from the manufacturer's catalog. In-house testing is sometimes needed to judge the remaining usability of solder paste after a period of use. Slump, the characteristic of a material's tendency to spread after application. Theoretically, the paste sidewalls are perfectly straight after the paste is deposited on the circuit board, and it will remain like that until the part placement. If the paste has a high slump value, it might deviate from the expected behavior, as now the paste sidewalls are not perfectly straight. A paste slump should be minimized, as slump creates the risk of forming solder bridges between two adjacent lands, creating a short circuit. Working life, the amount of times solder paste can stay on a stencil without affecting its printing properties. The paste manufacturer provides this value. Use. Solder paste is typically used in a screen printing process, in which paste is deposited over a stainless steel or polyester mask to create the desired pattern on a printed circuit board. The paste may be dispensed pneumatically, by pin transfer, or by jet printing. As well as forming the solder joint itself, the paste carrier flux must have sufficient tackiness to hold the components while the assembly passes through the various manufacturing processes, perhaps moved around the factory. Printing is followed by preheating and reflow. The paste manufacturer will suggest a suitable reflow temperature profile to suit their individual paste. However, one can expend too much energy on this. The main requirement is a gentle rise in temperature to prevent explosive expansion, yet activate the flux. Thereafter, the solder melts. The time in this area is known as time above liquidus. A reasonably rapid cool-down period is required after this time. A good tin lead solder joint will be shiny and relatively concave. This will be less so with lead-free solders. As with all fluxes used in electronics, residues left behind may be harmful to the circuit, and standards exist to measure the safety of the residues left behind. In most countries, no clean solder pastes are the most common. In the United States, water-soluble pastes are common. Storage: solder paste should be stored in an airtight container at low, but above freezing, temperatures. It should be warmed to room temperature for use. Exposure of the solder particles, in their raw powder form, to air causes them to oxidize, so exposure should be minimized. See also, flux, helping hand, solder, soldering, wave soldering, reflow soldering, restriction of hazardous substances directive, non-Newtonian fluid. References. External links: Advanced Solder Paste Dispensing, from the July 2008 edition of Surface Mount Technology, White Paper about Stencil Cleaning Fabrics by Dennis O'Brien.